What's up everyone and welcome back to my channel. In my last video I presented a microservice architecture application for the Guardian newspaper. In that video I deployed everything using Docker Compose, but Docker Compose is mostly used for development stages. Now, we are going to go in the production, and for that we are going to deploy everything in Kubernetes. So stick with me while we dive into the world of Kubernetes. So what is Kubernetes? Well, a lot of you may know that it is a container orchestrator, blah blah blah, some buzzwords about it. The perfect thing. Well, what I want to call Kubernetes, it is that it is the private cloud. So basically you want to deploy something on there, your application or whatever service you want, and you use images for that. So you have your application tagged as an image, most often used as a Docker image, and you deploy it on deployments, pods, and containers then. So that is what I want to think about Kubernetes. And why is Kubernetes important? Well, first of all, it is open source, so you can deploy the cluster, the Kubernetes cluster, wherever you want. You can use on-premise servers, or you can use another cloud provider such as AWS and build your cluster into that. Well, beside that, we have thousands of providers on Kubernetes. Since it is open source, a lot of companies have invested their time on building controllers, application on top of Kubernetes. That is the beauty of it, that you can use whatever you want. Most of them are open source, and yeah, you can build your whole application. But it succeeds mostly on microservice architecture when you have hundreds and thousands of microservices. So this was the architecture that we had previously. We have a front-end application, data collector, index creator, topic modeling, mallet. So all of those were our microservices. We had our database, MongoDB, and ElasticSearch for indexing and searching. So now all of those were deployed using Docker Compose. If you remember, you can also check the video. All of those were in this Docker Compose.yaml file, and I configured everything deploying all of them. Now, we are going to translate this architecture into Kubernetes icons, let's say. So let's see how that looks. Now, we have a lot of objects. Kubernetes is not simple. You need to know what objects are on Kubernetes and how to architect them. So let's see here. So we have the front end, we have the collector in here, the indexer, topic modeling, the Mongo Express if we want to front our MongoDB, the MongoDB itself, the Elasticsearch, and that is not the only thing. We have other objects that helps those our application to work well. So we have configuration maps, secrets, persistent volume and persistent volume claims, Ingress. We have a lot of objects in here. And all of those are deployed using Kubernetes Manifest. So everything is declared as code on YAML code syntax. And we deployed using Kubectl command apply. Now, to deploy all of those, we need a cluster. And to deploy all of this, I have selected AWS as our cloud provider, and we're going to create an Elastic Kubernetes service. I do have an old template that I have created on Terraform 2 years ago to create a Kubernetes cluster, and I'm going to use that because I have already created one. That's why. So let's see how to create the Kubernetes cluster, what it has, its component on Terraform, its resources, and we will go back to the Kubernetes world again. So this is the root module for our Kubernetes cluster. I'm calling a module on folder modulus EKS. And yes, passing some input variables, naming prefix, tags, cluster name, and this is the main.tf inside of that module. What we have, it is a role for EKS itself, some policies that are attached to this role, the cluster itself, security group roles for the worker nodes, IAM role for the node group role, policies for that, and the node group itself. Also some variables about the instance type and yeah, all of those desired size, which are on the variables.tf. Now, we are going to deploy it using Terraform. So Terraform init, Terraform apply, auto approve. Now, this might take some minutes, 10 to 15 minutes. So while we wait for that, let's see what we're going to deploy inside of this cluster. So let's start with our front end, right? Our front end. Now, everything that we're going to deploy is using manifest file. Basically, it is a YAML syntax piece of code that declares what we want to build inside of this Kubernetes cluster. Some basic stuff. We have the Docker image. Now, this Docker image, when you want to run it, you run it as a container, mostly on Docker environment. In Kubernetes, the smallest object that you can deploy, it is a pod. Basically, a pod is one or more containers that are run in Kubernetes. If this pod is replicated with some replicas of the same image, that is a replica set. And in case you want to add some features of self-healing and also rolling updates in that, well, that is a deployment. Everyone uses deployment. They are very simple to configure and have everything in one piece of code, so you do not need to declare anything else. Now, the deployment, the kind is deployment. We specify 3 replicas in there. We add some labels, so it will be found from the services on the cluster. So the app front end, it is the label, and in here we have the container. The container called front end, and it has this image. It exposes port 80, and we also insert some environment variables. Now, let's see side by side how it was on Docker Compose and how it is on Kubernetes. Let's go to front end. As you saw, similarly, we have basically replicated everything from Docker Compose to Kubernetes. And if you see the environment, we have inserted those URLs for collector, indexer, and topic modeling. But in Docker Compose was localhost. In here, it is basically empty. But in case I'm doing some testing, then I can change it on the services names. Now, we deploy the deployment for the front end, the image itself, and we need to front it. Now, Kubernetes does not work with, it works with IP, but in case you have multiple pods deployed with a replica set or with a deployment, you need a service. A service, basically, it's like a load balancer. It is a layer, it is a front door to your deployment, and based on labels, so the selector here, app frontend, all the pods that have this label, this service is going to front. Now, the ports, target port is port 80, it is similar to container port, and it exposes port 80 itself on the cluster IP. Now, when you deploy it, you need to define the type of the service. Either it is cluster IP or node port or load balancer. Now, for that, I need a whole other video to explain everything, but for the moment, we are going to deploy node port for that. Now, frontend is finished. There is nothing there. Let's start with collector. So our collector, side by side, this is the Docker Compose configuration, and this is our Kubernetes manifest file. Similarly, deployment, 3 replicas, this is the image on the container, and we insert some environment variables. Now, in here it is plain text. This is a big no-no, because in case you want to push this on a GitHub repository, well, everyone will see it. So what do we do in Kubernetes? We create a secret. Here's a secret. Secret is another object that you insert key value pairs. The value is basically encoded on base 64, and when you want to get the value, you just declare as environment variables value from secret key reference, the name, and also the key. So the Guardian API key, it will be the same as the value of this key right here. So this value decoded on base 64, it will be inserted or injected into the container. Now, this is the way that we insert secret components, secret configuration. For basic configuration, we create ConfigMaps, and we will see that later in other objects. Now, similarly, we create a service. The target port is 8080 because it's similar to container port, and it exposes on port 80 itself. And it is also a type node port. Collector finished, and let's go with the indexer. Similarly, deployment, 3 replicas, the image, container port 8080. We inject some environment variables similarly as the collector itself. We get it from the secret key reference from here. and we expose it with the service. Now, if you can see, I have also created a startup probe. Basically, it says wait 50 seconds before you deploy the container. Why? Because the indexer needs to have the ElasticSearch up and running. That is why. So I've just made it an initial delay 50 seconds. The last one, it is topic modeling. Similarly, deployment, 3 replicas, container port 8080, the image. I have injected some environment variables and also the service. Now, we finished with our microservices. Let's see how the MongoDB and ElasticSearch is deployed. So let's have a look on our MongoDB. I've specified it as a pod, not as a deployment, so it's going to be only one pod deployed for this MongoDB. Labels, similarly, container, the name and the image, container port, which exposed. I've injected some environment variables, and I have mounted 2 volumes. The first volume, it is for init Mongo configuration. If you saw my last video on the MongoDB, I have specified this script, mongo.js, as the initial code that will run on Mongo. So basically, it's going to create this collection. Now, I have created this similarly, but with the config map. Now, on the config map, I specified the data in here, and this will be injected as a file or as a volume inside of this container. The second container is MongoDB. Since working with databases is quite complex on Kubernetes, you need to use volumes for that. And for that, I've created a persistent volume and persistent volume claim. You can have it as external, but for the video, I've specified it as host path. That is the reason. It is very easy. I do not have to work with container storage interface. So yeah, I've created the volumes in here, and the first volume is a persistent volume claim name Mongo PVC. Now, there is another pod of Mongo Express pod, and the service that exposes the Mongo database pod. The config map that I just showed, and here are the persistent volume claim, and storage class. Persistent volume specifies the storage class name, the storage capacity, and where do you want it to get. So basically it is host path on the worker node. Storage class and persistent volume claim, you specify the access mode and also what is going to be the storage of it. So that is for our MongoDB. Similarly, ElasticSearch, you need to save the data. So also the pod of ElasticSearch, I have implemented a volume mount for all the ElasticSearch data in it. Now, the config map has all the configurations from the Docker Compose. If you can see in here, I've specified everything on a config map, and the pod of ElasticSearch pod, an init container, just to copy this configuration file into the actual container, and injected some volumes. Also some secrets in here, such as elastic username and elastic password, volume mounts, volumes, and the service for the ElasticSearch. Here is the code for the persistent volume itself, the storage class, and persistent volume claim. Working with storages in Kubernetes is complex, so you need another video for that. I will not explain everything in detail, but those are all the microservices that I am going to deploy. Now, the last thing that has left, it is the Ingress. Now, the Ingress, basically, it is a load balancer. Based on where you are deploying your cluster, you need to specify an Ingress so you can expose all of your applications. Let's have a look on what the Ingress looks like. Now, since Ingress is a load balancer, we are going to enable also HTTPS, and for that we need a certificate ARN. I have already created a certificate in here and validated with Route 53, and this is the ARN of that certificate. So we can just copy and paste it, and it is ready. Now, also we need our subnets, because it's going to deploy a load balancer, and for that it needs subnets. Now, if we go to our instances, we can copy the subnets in here based on our actual instances that are created. And yeah, another configuration is the scheme, which is an internet facing, so it is open to everyone. Some tags, SSL redirection. So basically all the calls on port 80, it's going to be redirected to port 443. Now, here is the routing rules. We have our host on right here, and if it is on HTTP path, let me remove this in here. If it is on HTTP / it's going to be redirected to frontend minus SVC, so the service of the frontend on port 80. /API collect, it's going to be collector service, API index, it's indexer service, and API analyze, it is the topic modeling service. Now, to deploy this Ingress, we need to install load balancer, application load balancer controller in it. And for that, I have already created some script that I'm going to run right now and deploy it on our Kubernetes cluster because it has already finished. Yeah, so everything is created and we have our cluster up and ready. Yeah. So let's see how we are going to install the application load balancer controller. So how to install application load balancer controller to an EKS cluster? First of all, we create the cluster, which is already finished, and we create an OIDC provider for the cluster. So basically we go to cluster, we copy this OIDC provider, we open IAM. On the IAM, we create an identity provider. So identity provider, we add a provider in here, open ID, and this is the URL. Now, for the second thing is audience, which is sts amazon avs.com. sts.aws amazon avs.com. Yep, that is correct. And create provider. Step 3 is check plugins if they are compatible with the smallest version. Well, they are because I'm using version 1.31. And step 4 is we are going to run all of those commands. So after, yeah, the identity provider is created, and let's go now. So export all of those. First of all, let's open a new, let's go to temp, make dir Kubernetes, and Kubernetes. Okay, so let's run all of those. Oh, it is copied it wrong. Let's run it. Okay, the provider ID is correct. Now let's do this one. Okay, correct. Load balancer. If we do cat load balancer, is that okay? Okay, that is okay. We create a role and we attach this policy that we just created. Okay, that role already exists because I've already done it before. Create a load balancer file, controller service account, YAML. We update the kubeconfig. Yeah, since it is up and running. We apply the load balancer control service account. We get the instance ID. Now for each instance, since this is using Linux 2, I believe, not 2023, I need to modify this metadata so the worker nodes are going to be able to get the VPC ID. Now checking it, it is applied. Step 5 is installing Chart Manager on the Kubernetes itself. And step 6, it is going to install the controller itself. So certificate manager is getting created. Here, kubectl get all system. Some of them are created. Now we run this and we deploy everything that we need. And on the end, we can verify it. It is already up and running, so 1 out of 1 is ready, and we are now able to deploy everything that we have. But first of all, we need to check if our images are on the ECR. So basically all of our images are on my local host. So we can go to the container registry. In case you're using another repository or registry such as JFrog, you need to modify the images there. But I have my own registry and all my images are in here. Let me just modify the image tag. So if we go to, let's go to front end, change this into this. So our files are going to be changed, and we can apply kubectl apply -f everything. And yeah, that was on the deployment phase. So everything is up and running, I believe, beside the indexer. kubectl get pods. So some of them are creating, some of them are waiting, pod initializing. We do watch. Yeah, so the indexer, as you can see, it is 0 out of 1 because it is still waiting 50 seconds of the startup probe. Okay, so everything is deployed. We ran in some complication with the indexer. It needed like 3 restarts to complete, but it is up and running. Now, we can see also the ingress, kubectl get ingress, and we can see that it is deployed. And if we can go to load balancer right here, it is active. Now we need to insert a new record into Route 53 for our load balancer. So to our hosted zone, soft plat, similar to the certificate that we just created, specify alias for the application load balancer, Frankfurt, and we specify the load balancer that we have. Now we create the record, and yeah, the record is created. We can copy it and we can check our website. Similar to the last video, it has 2 queries. So we did previously elections, so we're going to stick with that. We can go from November and elections. Collecting data, indexing data, and data is pulled and indexed. So everything is created and everything is saved on Elasticsearch and also MongoDB. Now, if we want to do, we did it with Trump last time. We can make like 8 topic numbers and 10 words per topic. Submit. So yeah, all of our microservices worked. They are up and running. The output is correct, similar to the previous video that we did with Docker Compose. So since we finished, first of all, let's clean up, and then we are going to see a recap. To clean up, first of all, we are going to delete everything. So kubectl delete with -f on here. And while this gets deleted, we will see also the load balancer that will start. Yeah, it is terminated. And wait some seconds. And after this gets deleted, well, you're going to need to delete some of the roles and also the identity provider that we created for OIDC and Terraform destroy, and everything is cleaned up, so we can continue with our Terraform destroy. In here, Terraform destroy. Okay, so those are deleted. Get pods. No pods are on the default namespace, and we can continue with destruction. Okay, while this continues, it's time for recap. So recap time. As you saw, we managed to deploy our microservice architecture for the Guardian newspaper topic modeling. Now, we managed to build a Kubernetes cluster using AWS EKS service. With Terraform, we deployed everything, and after that, we deleted everything. We installed application load balancer Ingress controller, which made us able to create ingresses, make our application public, and we deployed everything using manifest files. So as you saw, we had all of our objects as manifest file, and with one command, everything was up and running. Now, Kubernetes is fantastic, but it has its trade-offs. If you are working with microservice architecture and you have hundreds and thousands of microservices that you want to deploy, that is great. Use Kubernetes. It is open source, it is free, and even you can build the cluster yourself without using also cloud providers. If you have a two-tier application, do not bother with it. Kubernetes, you are shifting to another environment, and that has a lot of problems when you work with small application. Now, this is not the end. Why? Because we have not managed yet the continuous integration and continuous delivery. In Kubernetes, it is quite different from what we have done with EC2 instances and Lambdas. So wait for the next video when we will see how to manage the pipelines on Kubernetes. And after that, I have a very nice surprise for you that we will see what GitOps is. And in case you missed my latest video, right here you will learn about microservice architecture, the same application that we just deployed. And in this video, you will learn about website, web proxy, and web servers, what they are and how to deploy them. I hope you learned something and you had some fun, and see you next time.